Well, we're going to continue our work in solving equations. And so when we have an expression and an equal sign, this becomes an equation. The equal sign equates the left-hand side, which I'll usually abbreviate LHS, and the right-hand side, RHS. Now, technically in mathematics, this is a question. It says, is this equal to this? Or we could say this is a statement, and the statement is true when the two sides are equal, and it's false when they're not. And when we start putting variables in, that true or false can answer questions for us. But we always make the assumption that it's true when we do work on it. And so what we have is we have an expression on one side and an expression on the other side. And we're making a statement that the expressions are equal to each other. So what it says is, however much stuff is over here is the same amount of stuff over here. Our job then is to try to figure out what the unknown thing is, if possible, or the validity of the truth of this. So if we assume that it's true, well, whatever over here, I can subtract 5 from it. But because this thing is equal to this, that means I also have to subtract 5 from over here. And 5 minus 5 is 0. So that goes away. And 9 minus 5 is 4. And what this tells me is if x was 4, this initial thing I started out would be true. When we plot 4 in for x, we get 4 plus 5 is 9. It works. But this is the only thing that keeps this true. And so that's how we talk about solving equations. We work to see if the truth is there. So we can do this first. We can look to see if certain values do solve an equation. So let's say I have 2y plus 1 equals negative 3. And I want to know if y equals negative 2 is a solution. Well, I'll test the truth. So I will plop in negative 2 for y. Again, I use parentheses. And since I have only a number on the right-hand side, and I have my variable substitute on the left-hand side, I'll only work on the left-hand side. So 2 times negative 2 is negative 4. And negative 4 plus 1 is negative 3. And when I look at this, this is true, which means that, yes, this is a solution. And so what we want to do is to find a solution, solve for a particular unknown variable. So if I have some equation that equates this quantity to this quantity, my two expressions, I want to find the number in x that keeps this true. What we tend to do is we work the order of operations backwards and we try to undo what's happening. We say we isolate the variable. I want to get x equals some number. So what I have to do is I have to get everything away from x. I always think of it as like peeling off onion skins, mainly because of Shrek, right? Ogres are like onions, they have layers. These equations have layers, and we want to peel apart the pieces. So this is saying I'm taking 4 away from x. So I want to undo that. And to undo a subtraction, I add. But whatever you do to one side, you have to do to the other. because this quantity was equal to this quantity. So if I raise this up 4, I have to raise the other side up 4. Now negative 4 plus 4 is 0. So I've got my solution. And I can always go back and check. So I'll plug it into the original problem. And I get 3 equals 3. So yeah, that is a solution. We're able to work on it. Always check your answers. If you make a small mistake, checking can usually help catch it. And we have all these sign rules and everything. It's easy to miss a negative sign you wrote down. All right, so here I'm going to use z as my variable. Now notice my variable's on the right-hand side. That doesn't matter. I can still isolate it. And so here I'm adding 8 to z. So to undo it, I'll subtract 8 from that side. But whatever I do to one side, I have to do to the other. These become 0. So I'm left with z on its own. And negative 2 minus 8 is minus 10. And now I check. Negative 2 equals minus 10 plus 8. I subtract and keep the larger sign. And yeah, that works. Well, the same thing can happen with multiplication. We can get multiplications in equations. So if I have 4x equals 8, I'm saying I'm taking whatever this number was and I'm multiplying it by 4. So if I want to undo that, I have to divide by 4. But whatever I do to one side, I have to do to the other to keep the equality true. And 4 divided by 4 is 1. And 8 divided by 4 is 2. Well, let's check. 4 times 2, 8 equals 8. So yeah, it worked. It checked back for us. And so when we start solving equations, we can think about it as reversing the order of operations that we did to one side to isolate the variable. Let's look at one more to isolate the variable that has a division in it. Oops, almost out of Blackboard. Let's do this. So if I have x and I've divided it by negative 4, and that gives me 7, well, if I want to find x, I have to reverse this division. And to reverse a division, we multiply. And so I'm going to multiply by negative 4, but whatever you do to one side, you do to the other. And negative 4 divided by negative 4 is 1. So that leaves me with x over here. And 7 times negative 4 is negative 28. Well, I'll check. I'll put negative 28 in for x and negative 4 below it. Negative divided by a negative is positive, and 28 divided by 4 is 7. So it checks, and this is a solution. And so when we do equations, we can think of undoing all the order of operations we did around the x. We isolate the variable. And these finish the lectures for Chapter 2.